Hello there, welcome back. What we're going to do is take a look at a known definite integral, the integral from 1 to 4 of f of x dx, and its value is 12. And we're going to use it to evaluate the integral from 1 to 4 of f of x plus x dx. And that's going to be by using the various properties of definite integrals that we've learned. So the first property, remember, is that when you have a sum as your integrand, we can break the definite integral into pieces. So this is the integral from 1 to 4 of f of x dx plus the integral from 1 to 4 of just x dx. Now, we already know that the value of this first definite integral is 12, and because it's a known formula, a known shape, I should say, we know what the definite integral of f of x equals x is. So I just sketch a graph of that. And we have our axes here. Y equals x is the diagonal line making a 45-degree angle with the x-axis. And we have x equals 1 here and x equals 4 here. Now, since the region is above the x-axis on the interval 1 to 4, we know that the definite integral from 1 to 4 is the area of said region, which is in the shape of a trapezoid. So the height of this side here is 1, the height of this side here is 4. Those are your parallel bases. And then what we call the height of the trapezoid, the side that's perpendicular to the parallel bases, is 3. So that means that this area is 1/2 times 3 times 1 plus 4, which looks to be 15/2. So that means that this second definite integral, which I'm going to have to go to the next line here, has value 15/2, since again, it's the area of the region because the region is above the x-axis. So that means this is equal to 12 plus 15/2, which is 7.5. So I can write this as either 19.5 or 39/2. And that is using properties to evaluate a definite integral.